Welcome back, my dear students. Someone said some folks are wise and some are otherwise. हमारा आज का जो टॉपिक है branches of physics. So many students have asked from me on the WhatsApp that, sir, will you teach the third, fourth and fifth period of the history of physics? तो उनके लिए मैं कह दूं कि जो तीसरा, चौथा और पांचवा दौर है फिजिक्स का, वो हम इसलिए टेक्स्ट में इंक्लूडेड नहीं है क्योंकि आप थर्ड चैप्टर मैकेनिक्स से जो भी आगे पढ़ना शुरू करते हैं अप टू द मॉडर्न फिजिक्स, तो वो तीनों अदवार उसमें कवर हो जाते हैं. यानी जो पूरी फिजिक्स आप पढ़ेंगे वो सारी फिजिक्स उन तीन अदवार से रिलेटेड है, तो उसको अलग पढ़ाया नहीं जाता. वो जो कुछ भी आप पढ़ेंगे वो उसमें तीनों अदवार शामिल हैं, न्यूटन से लेकर आइंस्टाइन तक. So today our topic is the branches of physics. As you know that physics has been developed a lot, so that is why it is divided into some groups या classes or parts. Basically there are two classes or two groups या two branches of the physics. One is the older one, that is also known as the classical physics. Second one is the new one, that is also known as the modern physics. Classical physics, sometimes known as the Newtonian physics, because this world is related to based on the mechanics, and mechanics is based on the Newton's laws of physics. That is why we can say the classical physics is also known as the Newtonian physics. And the modern physics is also known as the quantum physics because it has been started from the 1900 AD, and you know that in 1900 AD Max Planck, a German physicist, proposed his famous theory that is known as the quantum theory, or we can say Planck's law. That quantum theory actually was given by the Max Planck to explain the black body radiation curves problem. You will study in the modern physics that what was the problem of the black body radiation curves, and that was successfully explained by the Max Planck in 1900 AD by his famous theory, Planck's quantum theory. So before 1900 AD, physics was comprised of some branches, and that group of branches is actually known as the classical physics. So classical physics is not a single branch, but classical physics actually consists of a group of branches. That group is collectively known as the classical physics. Actually, this is the physics which was developed before 1900 AD. Sometimes it is written that 1890 AD, it's okay. And the modern physics is actually related, started from the 1900 AD to the onward. Okay, let's start from the classical physics, means all physics are Newtonian physics. First of all, you have to remember that the most important branch of the classical physics is the mechanics. We can say mechanics is also the basic branch of the whole physics, because without understanding mechanics we cannot understand the physics completely or clearly. It is impossible, because the whole physics is based on the mechanics. Without understanding the terms of mechanics we cannot talk about any other branch of the physics. So it means very important one is the mechanics. Actually, mechanics, you know that mechanics word is related to motion, so we can say mechanics is the branch of classical physics which deals with the study of the motion of particles under the action of force. Or we can say in this branch we study about the cause and effects of forces. Cause and effects. Cause is the force and motion is its effects. So whenever we study about the cause and effects of the forces and motion, that is actually known as the mechanics. Mechanics developed a lot, therefore it is again subdivided into three parts. One is the statics, other is the kinematics, third one is the dynamics. In statics, we study about the bodies at rest. We can say it deals with the study of the bodies at rest under the action of force. When I say this book is placed on the table and it is at rest, it is in equilibrium. So this equilibrium will be studied in the statics. Why it is in equilibrium? Because in static equilibrium, because the forces acting on the book are being balanced with each other. So when all forces, if all forces are cancelled out with each other, then the body will remain at rest in equilibrium. So such type of problems are studied in the statics. Okay, come to the second part of the mechanics. That one is the kinematics. Whenever we say kinematics, means we are talking about the motion, but just motion, not its cause of motion. It means we can say kinematics is actually the part of mechanics in which we study about the motion of bodies but without consideration of force. You will say, sir, how? So I will give you examples. Whenever you explain the velocity, it means you know that velocity is related to motion. Velocity जिसको आप speed कह सकते हैं, उसको थोड़ा फर्क होता है लेकिन आगे समझेंगे. या रफ्तार कहते हैं. रफ्तार का मतलब होता है कि कोई भी बॉडी हरकत कर रही है, कोई भी बॉडी मोशन में है. लेकिन इस वेलोसिटी को एक्सप्लेन कैसे करते हैं, डिफाइन कैसे करते हैं? You know that velocity is defined as the rate of change of displacement with respect to time. So velocity is defined in terms of displacement in time but without considering the force. So velocity will be studied in the kinematics, this definition of velocity. As you know that acceleration is defined as the rate of change of velocity with respect to time. So we can say acceleration is a kinematic term because it is studied in kinematics, and acceleration is defined without mentioning the force here in kinematics. So that is why this type of definition is related to kinematics. As you are very familiar with the equations of motion, first equation of motion, third equation of motion, and the fourth equation of motion. In all these equations of motion, yes, we study about the motion but without any consideration of force. So all these equations of motion are also related to the kinematics. It means in kinematics we study about the motion but without consideration of force. So that is kinematics. Okay, third one part is the dynamics. Word itself expresses the force. Kinematics, just motion. Dynamics, it means motion, having a powerful motion, means having the consideration of the force. In dynamics we can say we study about the motion of particles but under the consideration of force. You will say, sir, which type of topics are related to the dynamics? I will say that Newton's laws of motion are related to dynamics, because in all three laws of motion you study about the force as well as its effects. Effects means motion. For example, in Newton's second law you say that when we apply force on a body, then it is accelerated in the direction of force. So here in the second law it is stated that motion is produced due to its cause of force. So whenever we say Newton's second law, quantitatively written as this, force is the product of mass and acceleration. We can say acceleration is also defined as the ratio of force to the mass. We can say acceleration due to gravity is defined as the weight of the body to the mass of the body. So all these topics will be related to the dynamics, because in all these topics we study about the motion but under the consideration of the force. So all Newton's laws of motion are related to the dynamics. In third chapter of the first year class we will study about the kinematics as well as dynamics, and statics is also somewhat is there. Okay, so these were the three parts of mechanics, and we have to remember that mechanics is one, the famous and basic and important branch of the classical physics. Yes, my dear students, after mechanics, the next important branch of the classical physics is the optics. Optics is actually the scientific study of light, and for studying about the different phenomena or properties of light, we use two types of scientific models. First model was developed by the Newton, that light always travels along the straight line, and these straight lines are known as the rays. So that is why Newton's model is known as the ray model. And the second model was developed by the Christian Huygens, a Dutch physicist, and he was also contemporary of the Newton. तो क्रिश्चियन हाइजन ने कहा था कि नहीं, लाइट वेव्स की शक्ल में एक जगह से दूसरी जगह जाती हैं, तो उसने एक नए मॉडल की तश्कील की जिसको हम कहते हैं वेव मॉडल. So we can say there are two types of model. One is the ray model, other one is the wave model. For the some properties of light we use the wave model, and for the understanding of other properties we use the ray model. As you know that in 9th chapter we use the wave model to understand the interference of light, diffraction of light and polarization of light. But in the 10th chapter we use the ray model, for especially for the refraction of light, for the reflection of light. So simply we can say there are two types of models for the study of the light. One is the wave model, other is the ray model. Wave model, on the basis of wave model, the study of light is known as the wave optics. Wave optics is also known as the physical optics. That is actually your 9th chapter of the first year class. And the ray optics is also known as the geometrical optics, and that is included in your 8th chapter of the first year class. So now conclude this. Optics means scientific study of light, and it is divided into two parts. One is the wave optics or physical optics, and other is the ray optics or geometrical optics. In wave optics we study about the nature of light, interference, diffraction and polarization of light. In the ray optics we study about the refraction and reflection of light, especially on the basis of ray optics we can understand the different optical instruments, just like the microscope, telescope, these glasses, etc., spectrometer. Yes, now third branch is electricity. Electricity means study of electric charges. And you know that electric charge, what is electric charge? Electric charge is the property of elementary particles by which they either attract each other or one another. And such type of property was observed on the electron. So that is why electron is charged particle, but we say it is negatively charged particle. Proton has also charge, that is known as positively charged particle. But proton is further divided into three particles, means proton is nowadays not a basic particle, not an elementary particle. Proton has been divided or split up into three different quarks, and quarks are elementary particles. Proton consists of two ups and one down. These are the names of the quarks, elementary particles. Two are the ups, one is the down. And suppose the charge of proton is actually, you know that 1.6 into 10 power minus 19 coulomb. And if we consider this as one positive charge, suppose this value is considered as plus 1, then the charge of one up is actually 2/3, and second up has again same charge of 2/3, and the charge of down particle is actually negative 1/3. If you add all these charges, you will get the value of the plus 1. So I think it is very interesting that proton is not an elementary or basic particle. It is further divided into three particles, three quarks, two are the ups, one is the down, and by the combination of two ups and down we have the proton. And you know that neutron is a neutral particle, it has no any charge, so it has no any basic instinct to attract or repel another particle. So simply we say that neutron has no any charge, so that is why it is known as the neutral particle. So it was named as neutron by James Chadwick. Neutron actually consists of charged particles, but neutron as a whole is neutral. You know that atom as a whole is neutral, but it consists of protons and electrons. But the number of protons is always equal to the number of electrons. That is why atom is known as the neutral particle, neutral body. And similarly, neutron is neutral, but actually neutron consists of two downs and one up. Two down means two negative one-third charges, and one up has the two-third of the positive charge. Again you get the sum of these charges, then the charge value will be equal to 0. It means neutron is a neutral particle. Neutron has no charge, but actually neutron consists of three elementary particles, two down, one up. What are the down and ups? Actually these are the quarks, elementary particles, by which neutron and protons are produced. Electron is a kind of lepton particle. This type of study is not included in your textbook, but for your interest I am telling you, neutron is still elementary particle. We have not been able to divide into further other particles. So we can say electron belongs to the family of lepton, and the quarks, neutron and proton belong to the family of the quarks, because the proton and neutrons are made of the quarks. So now I am going to conclude this discussion. We can say elementary particles have property to attract or repel one another. That property is known as the electric charge, and whenever we want to study about these charges, that is known as the electricity. Electricity is again divided into two branches, sub-branches. One is the electrostatics, that is also known as the static electricity. Second one is the electrodynamics, that is also known as the current electricity. I think it will be clear from the meaning of these words. Electrostatic means study of charges at rest. Electrodynamics means study of charges in motion. Whenever we study about the current in these conductors, that is related to electrodynamics. Whenever we want the study of charges on any body and they remain at rest, so such type of bodies are known as the electrostatic bodies, electrostatic charges, and their study is known as the electrostatics. I hope that will be clear. Fourth important branch is the heat and thermodynamics. In this branch, we actually study about the nature of heat, and thermodynamics means conversion of heat into kinetic energy. So conversion of heat energy into mechanical energy is known as the thermodynamics. If you break down this word into two parts, thermos and dynamics. Thermos means heat, dynamics means motion. So we can say thermodynamics means conversion of heat energy into some kind of mechanical energy. This is performed by the heat engine. So we can say heat engine has been developed on the basis of knowledge of thermodynamics. And thermodynamics is related to heat, and this knowledge is related to classical physics. Magnetism, very simple one. Magnetism deals with the properties, origin and uses of the magnets. So we can say study of magnets is known as the magnetism, and magnetism is again classical physics, a part of classical physics, because yesterday I told you the magnet's directional property was identified by the Chinese. Okay, acoustics. Acoustics means scientific study of light. But in the next chapter we will study much more clearly about the acoustics, that acoustics is mostly related to the reproduction of sound. Whenever echo is produced, it means we can say reflection of sound. Whenever sound bounces back from any hard surface, that produces echo, that is also known as the acoustics. So scientific study of the sound, especially reproduction of sound, is known as the acoustics. Okay, these were the famous branches, or we can say main branches of the classical physics. Yes, my dear students, after classical physics we have very important, very interesting part of the physics, that is known as the modern physics, and you will study about this part of the physics in the intermediate class from the 17th chapter, 17th, 16th, 17th, 18th, 19th, and they are related to modern physics. You will proceed. Actually, modern physics starts from the 1900 AD. Sometimes we say from the 1890 AD. When Max Planck proposed his famous quantum theory for the explanation of the black body radiation curves, that was totally new theory to explain the phenomena related to the interaction between the radiations and matter. We will study in the modern physics. So that theory actually became the basis of the new world of the physics. If quantum theory was not there, we can't even imagine about these branches of the modern physics. So that was the revolutionary theory. After his revolutionary theory, we have the theory of relativity of Sir Albert Einstein. So that's why we can say these theories became the basis of the modern physics. That's why modern physics is also known as the quantum physics. But modern physics again has been developed a lot, and it is again subdivided into different branches. The main branches of the modern physics are, some of them are given your textbook. Okay, come to the first branch of the modern physics, that is known as the atomic physics. And from the name it is clear, it is related to the study of atoms. But atoms, as you know, always imagine that there is a nucleus and there is extra part of the nucleus. In extra part of nucleus, electrons are revolving there. That is the model of the atomic model. So whenever we study about this extra nuclear part of atom, that is known as the atomic physics. You have to be clear that in atomic physics actually the study of nucleus is not included. In atomic physics we simply study about the electrons which are revolving round the nuclei of the atoms, and this study is known as the atomic physics. Atomic models, you know that different atomic models are there. First one was Dalton's model, then J.J. Thomson's atomic model, then we have Rutherford's atomic model, and the new one is Bohr's atomic model, Schrodinger's model, Sommerfield's atomic model are there, but US study is only restricted up to Bohr's atomic model. So atomic physics is actually the study of the electrons which are revolving around the nuclei. And Bohr said that these electrons are not either and either, but these electrons are revolving in their fixed orbits. These are known as stationary states, also energy states. Whenever electron jumps from higher energy level to the lower energy level, then it radiates out energy in the form of photons. And on the basis of these photons, Albert Einstein gave the concept of laser. So laser is most important and advanced technology of the present period. But the laser is the gift of atomic physics. So sometimes it is asked that laser is the gift of which branch of the physics. You can say it is the branch of the it is the gift of the atomic physics. Okay, after atomic physics we have nuclear physics. Very clear from the name that we will study about only the central core of atom. Whenever we study about the central core of atom, that is known as the nuclear physics. Simply we can say study of central core of atom, or we can say study of nuclei of atoms, or we can say study of the protons and neutrons, or we can say study of nucleons, because you know that the particles residing inside the nucleus are known as the nucleons. So a study of these nucleons is known as the nuclear physics. In nucleus we have discovered that there are protons, and number of protons is represented by the Z, and the neutrons are there and the number of neutrons is indicated by the N. So nucleus is made of protons and neutrons. But I told you the proton and neutrons have been subdivided into quarks, because they are made of quarks. So we can say quarks are the basic particles, and 2 ups and 1 down makes the proton, 2 down 1 up makes the 1 neutron. Okay, such type of study is included in the nuclear physics. But for you, you can say the study of nucleons is known as the nuclear physics. In nuclear physics, we especially study about the nuclear reactions. The most important reactions are the fission reaction and the fusion reaction. On the basis of fission reaction, we have developed the atomic bomb, and on the basis of fusion reactions, we have developed the hydrogen bomb. Most disaster bombs for the human beings. After atomic physics and nuclear physics, we have the molecular physics. Molecular physics is again the branch of modern physics which deals with the study of the properties of the matter, but on the basis of molecules. What's a molecule? You know that molecule is just a group of 2 or more than 2 atoms. As we know, 2 hydrogen atoms combine with each other by sharing 1 electron, 1 valence electron with each other. By formation of the covalent bond, it becomes a molecule. As you know that carbon dioxide molecule, oxygen molecule, etc. There are many examples. So we can say whenever we study about any type on properties of matter, but on the basis of the formation of their molecules, that is known as the molecular physics. So molecular physics is there. Fourth one is solid state physics. Very important branch of the modern physics is this, because this whole electronics has been developed on the basis of application of the solid state physics. This whole application of the electronics means all electronic appliances are formed on the basis of only the application of the solid state physics. In solid state physics, we actually study about the crystalline structure of solids. You know that there are 2 types of solids. One is the amorphous solids, second one is the crystalline solids. So here we generally study about the crystalline solids. But which crystalline solids? Then we say semiconductor solids. What are the semiconductor solids? Those crystalline solids are materials having the properties of insulators as well as the conductors are known as the semiconductors. We will study about these semiconductors in the 16th chapter of the intermediate class. So you know that solid state physics is simply related to the semiconductors. Which are the most important semiconductors? Then you have to remember these examples of semiconductors: silicon, germanium, selenium. They are the very famous semiconductor conducting materials are there. And this whole electronics is actually the application of the solid state physics, because you will study in the coming chapters semiconductors are obtained After semiconductors, we form the p-type n-type materials. By connecting p and n-type materials, we can form a diode, and by combining two diodes, we can produce or can construct a transistor. By combining many transistors, we have integrated circuits, ICs, and by combining many ICs, we have a microchip, which is the part of your motherboard of the computer. So we can say computer is the electronic appliance, but it is formed on the basis of the knowledge of the semiconductors, and semiconductors are studied in the solid state physics. Very interesting. Okay, after solid state physics, we have plasma physics. As you know, some particles are molecules, some are atoms, but at a very high temperature. Suppose this one is the atom of hydrogen, but at a temperature of millions of degrees centigrade, such as on the surface of the sun, these atoms do not exist as they are here on the surface of Earth. They become separated, negatively charged electrons and positively charged nuclei. So any gas which consists of negatively charged electrons and positively charged nuclei is known as the highly ionized gas, and that highly ionized gas is known as the plasma. And the study of that plasma is known as the plasma physics. So we can say plasma is a different kind of material. It's a form of gas, but not a gas as we observe here on the surface of Earth. That is actually molecular gas, but this one is very highly ionized gas. It has different properties from these usual gases. So this type of gas is known as the fourth state of matter. So I think it will be clear for you. Plasma is a highly ionized gas that mostly exists on the stars, and we can say this gas exists at a very high temperature of millions of degrees centigrade, and this consists of negatively charged electrons and positively charged nuclei of different atoms, elements. So that type of gas is known as the plasma, and study of plasma is known as the plasma physics, and plasma is considered as the fourth state of matter. And nowadays scientists are mostly working to control the plasma, because plasma can be produced in the form of the during the fusion reactions. So if we become able to control the plasma, then we can produce the electricity from the fusion reactions. That is the future. Okay, after plasma physics, we have the elementary physics. Elementary physics is also known as the particle physics. Elementary physics, particle physics, sometimes it is also known as the high energy physics. As I mentioned you before, modern physics, that proton and neutrons consist of again little particles. They are elementary particles, quarks. Whenever we study about these quarks and leptons, because lepton is again you can say okay, you consider only electron and quarks, these are the elementary particles. Whenever we want to study about these particles, then how can we break up a neutron which is made of two ups and one down? At a very high energy is required. By applying very high energy, or we simply can say that whenever at a very high voltage, at a high energy, these particles are being revolved inside the cyclotron, betatron laboratories, and these particles suddenly collide with each other, and in the result protons and neutrons split up into their basic particles, elementary particles. Then we can observe the properties of the quarks, ups, downs, charms, strange particles. These are actually the names of elementary particles. A very interesting branch is this one, and this book is related to this branch. Very interesting book is this, The Particle Zoo. Particle Zoo. Those particles which are included in the these particles are the base of our universe. If you want to understand the whole universe, you have to study this branch. That is known as elementary physics, particle physics, or we can say high energy physics. Very interesting one. Okay, come to the last one. There are other branches too, but in your textbook these only branches are mentioned, so we have discussed them only. Others are overlapping branches. Overlapping branches means they are not totally about the physics, but in these branches physics is playing an important role in other branch of the science. For example, physical chemistry. The first year chemistry you study usually in colleges, that is physical chemistry. Physical chemistry is an overlapping branch. It means it is the combination of physics plus chemistry. Because in chemistry you have to study about the covalent bonds and ionic bonds. Covalent bonds and ionic bonds, these are the two kinds of forces. Yeah, different kinds of bonding means forces, and the nature of forces is studied in the physics. So we can say physical chemistry is actually the combination of physics plus chemistry. So the application of the laws of physics in the chemistry, and that is known as the physical chemistry, you can say. Astrophysics means the study of the motion of heavenly bodies. Whenever we can say the study of particles in space. Study of particles in space is known as the astrophysics. But astrophysics is not only the physics, but it is the combination of physics plus astronomy. Okay, simply we can say the laws of physics which are applicable in astronomy are known as astrophysics. Biophysics means whenever the laws of physics are applicable for the living things, that is biophysics. Laws of physics which are applicable in the geology, geophysics. Laws of physics which are applicable in the music world, that is music physics, musical physics. Oceanographic physics is there. So these are the overlapping branches. I think you will be cleared.